Hello, and today we're going to learn how to solve exponential equations using one method. The first method and the easiest one is if you can find like bases for both sides of your equation. So we're going to try to do that today. Eventually we're going to get to something a little more complex, but not for this video. So for this video we're going to start off with something like 2 to the x plus 2 is equal to 8 to the x. Okay, so the goal would be to get these bases to be exactly the same. Now you can't manipulate the bases. The only thing you can do is rewrite the bases. So 2 to the x plus 2, I can't really rewrite it as anything to a power unless I wanted to make it very complicated for myself. But 8 I can write as a base of 2. I can rewrite 8 as 2 cubed. So 2 cubed and 8 are equivalent to each other. So notice I didn't do anything. I didn't operate on it. I just rewrote 8 as 2 cubed. And that would be raised to the x power. So now that we have the like base, and let me just simplify this side a little bit, so we have 2 to the x plus 2 is equal to 2 to the 3x. Well, if the bases are the same, then that means that we have to be raising it to the same power. So if my bases are exactly the same, I can set the exponents equal to each other. So x plus 2 is equal to 3x. And if we subtract x from both sides, we get 2 is equal to 2x, and therefore 1 is equal to x. So let's see if this makes sense. Substituting in 1. 1 plus 2 is 3. 2 cubed is 8. And then 8 to the first power is 8. So indeed, 1 is the value of x that makes this true. So again, just to summarize, we need to create a like base by rewriting these bases as the same base raised to a power. Okay, we did that. And then once the bases are exactly the same, we can set the exponents equal to each other. All right, let's try doing that with our second example. Here it's harder to see because we have a fraction on one side as a base and an integer on the other side. So is there anything that we could rewrite these both in terms of? And the answer is yes. We can rewrite 1/9 as 3 raised to, think, what power? 3 to the negative second would be 1/9. And we can rewrite 27 as 3 cubed. So again, notice I didn't perform any operations on these two bases. I simply rewrote this number as 3 raised to some power. We're going to use the power of a power rule. So 3 to the negative 2x is equal to 3 to the, distribute the 3 to be 3x minus 9. Now that my bases are exactly the same, I can set the exponents equal to each other. So negative 2x is equal to 3x minus 9. I'm going to add 2x to this side and add 2x to both sides and then add 9 to both sides. So I'm going to get a positive 9 over here and a 5x on this side. And then if I divide both sides by 5, I'm going to end up with x is equal to 9/5. Okay? If you really want that decimal equivalent, that'd be 1.8, but 9/5 is more than sufficient for me. So there you have it. That would be what both of these x values would have to be equal to. Okay? And the very last example, here it might be harder to see. A lot of people might get caught up in thinking that you could rewrite 8 as 4 to the second power, but 4 squared is 16, not 8. Instead, we notice that 4 and 8 can't be written in terms of each other as powers, but both can be written as 2 raised to some power. 4 is 2 squared, and 8 is 2 cubed. So don't fall into the trap. Using power of a power rule, we would multiply the exponent, so that would be 2 to the 4x is equal to, and then again we would multiply the exponent, so it would be 3x minus 15. Now that we have the exact same base, we can set the exponents equal to each other, so we have 4x is equal to 3x minus 15. Subtract 3x from both sides, we get x is equal to negative 15. So there's our solution. All right, and that's how you solve exponential equations by finding a common base.